Show that the equation at the top can be written as this. So we've gone from something involving tan, cos, sine, and sine 2 theta to something that just involves sine 2 theta and then a quadratic in cos. So I don't want to change this sine 2 theta. I think that's okay as it is. What I need to get is a sine 2 theta on the left-hand side. And the double angle formula for sine 2 theta is sine 2 theta equals 2 sine theta cos theta. Okay, so I'm going to look out for that. If you don't know that formula, then do learn it. Also learn how to derive it from the addition formulae. But like, be looking out for it because you could be asked, for example, to integrate this thing on the right, and then you just turn it into sine 2 theta, for example. One other thing that jumped out to me when I did this question is the 1 plus tan squared theta. So we've got this trig identity, sine squared plus cos squared is 1. If you divide through by sine squared, you get another identity. If you divide through by cos squared, you get another identity. And that's what I'm going to do here. We get tan squared plus 1 is sec squared. Okay, so I can actually just replace this and write it as 8 sine 2 theta over cos squared theta. When I originally did this question, I got to be honest, I expanded the left-hand side. In fact, there's no need. We can just straight away write 2 tan theta as 2 sine theta over cos theta, and then multiply both sides by that cos squared theta before expanding. In fact, we don't even need to expand. Because this cancels with this, and then we're actually left with 2 sine theta cos theta. This is sine 2 theta. In fact, I can minus that 8 sine 2 theta from both sides now. And then completely factorize it. So sine 2 theta, 8 cos theta plus. Now, I've got a sine squared still, so I'm going to replace that by 1 minus cos squared. And inside the bracket, I'm also going to minus 8 to account for this term here. And we're nearly there now. So I'll get plus 23 minus 23 cos squared theta minus 8. I'm just going to do 23 minus 8 to give me 15. And the only thing I need to do is rewrite the cos squared at the front just to make it a bit neater, but I'm also going to times through by, you don't have to do this, but by minus 1, which means I can flip all the signs inside this bracket to give me 23 cos squared theta minus 8 cos theta minus 15 equals 0. Okay, that is my final answer. Hence solve this equation in the range 360 to 540. So we can replace it by what we've just shown it to equal. I just need to replace my thetas by x's. Just one thing I want to bring your attention to, and that normally this isn't very relevant, but we can't have x equal to 450. In fact, that is a solution later on that we then need to reject. I'll talk more about it at the end. So two things multiplied together, either sine 2x is 0, or the function in the brackets is 0. So sine 2x is 0. We can do inverse sine, which actually gives 0. And then you can either use your Gauss diagram or draw your graph. We're also going to get it at 180, any multiple of 180. Do you know what? I just decided to write them all out. The thing is that we have an extended range. So I'm actually going all the way up to 1080. Okay, you might be able to skip the first few. We actually reject all of those and that one to leave us these three. That means x is going to be 360, just divided by 2 now, 450, or 540. But this is where the 450 comes in, actually. We are told that it can't equal that, so I'm going to reject it. In fact, you have to make sure you do that. For info, the reason we reject it, it's not just like an arbitrary condition put in. It's that if you go back to the original, this original equation before we've kind of rearranged it, then tan 450 actually doesn't exist. It's exactly the same as tan 90. So you'll get a math there. It's just in the process of using trig identities, multiplying through, we kind of lose that problem because we've times through by cos squared. That's actually the main reason, and then it's cancelled out partially with this tan. So it's like an extra condition that comes in. Actually, x can't equal any multiple of 90, to be fair. No, wait, no, it can't equal 90 or 270 or 450 um, because tan doesn't exist at those values. So it's kind of helping us out here. Technically, if it didn't say that, if it didn't say it, we'd have to realize in the process of timesing through by cos squared that we might introduce spurious solutions, and then we'd have to just check them. So it's something to just be aware of. The question's actually been a little bit kind, just basically pointing out that it's not equal to 450. If you're using your cast diagrams instead, by the way, you'd get this, and then inverse sine would give you 0, and then we'd also go here, and then so you get your 0, your 180, and you just keep adding on 180. Okay, it's a little bit strange for the cast diagram here, but you would get the same answers. All right, let's take a look at the hidden quadratic in cos. So you can either let u equal cos x, sorry, that should have been an x here, or you can just straight away factorize in terms of cos, or you can do your substitution and use your calc. Actually, the question does say not to use your calculator too much, so I'd probably try and factorize it here rather than just writing the solution straight down. Or if you want to get the solution, then try and like get the factorization from that just to show that you have done it. So if it's going to work, it's got to be 23 is a prime number, so it's got to be 23 cos x and cos x. Actually, the difference between 23 and 15 is 8. So we can put 15 here and 1 here, and it will all work out. That's a minus and that's a plus. So cos x is 1, or cos x is equal to minus 15 over 23. Actually, for cos x equaling 1, we get 0, then 360, 720, which we've gone beyond the range now because it was 360 to 540. So we reject that one, and that one we've already got the 360s. It's not a new solution. It's just that the right-hand term is also 0 for x is 360 as well as the left-hand term. That just leaves us to the only new solution, which is going to be cos x is minus 15 over 23. So we get 130.7. I'm going to write this down. I know I'm going to reject it in a minute. 130.7 70. Sorry, I'm just going to write down what I had earlier. And then, okay, for cos, I've already drawn the graph, but we can do 360 minus to get our second solution, which then gives 229.294. If you're using cast diagrams, by the way, then because cos of x is negative, we'd be looking here and here. We'd get, this is our first solution. Then you can see that we're going to do 360 minus that to get our second solution, because that angle there is also 130.7. And then after that, in both cases, we just keep adding on 360 until we're outside the range. In fact, we're outside the range at the moment, so we have to get into the range. So add on 360 to 130 gives 490.70. Add it on to 229 gives 589.29. So remember, it's 360 to 540, so I'm going to reject these two and this one, which means our answers are going to be these two and this one. I'm just going to write them finally together. X equals 360 degrees, 491 degrees. I think we're asked for three significant figures. Well, we weren't, but that's typically what you do. As long as your answer rounds to it, that's the main thing. And then 540 degrees. Okay, so slightly different trig question here with this double angle formula and this 450 that you have to be careful of, and then a hidden quadratic in cos. But those are the steps we do. Very well done.